Okay, we want to finish working the last examples 2 through 4. In this situation, I'm asking you to find the sine of 2 alpha. I've given you the sine of alpha to be a negative 3/5. I've told you that alpha is in the third quadrant because it lies between pi and 3 pi over 2. I'm thinking, well, where does 2 alpha lie? If I double this original angle, where will it lie? And it will lie between 2 pi and 3 pi, which means I'm going around a second rotation around my unit circle. So it would be lying in quadrants 1 and 2. And in those quadrants, sine will always be positive. Now, there's only one formula for finding the sine of 2 alpha. This is the formula I would have to be using, replacing u with alpha. I don't see a problem to start with because I know the sine of alpha, but when I start to plug in the cosine of alpha, I don't know that. So that takes us back to something we reviewed in first part of the semester. The sine of alpha is equivalent to y over r. Remember, we're in the third quadrant. My y value takes on the negative sign. My r is always positive. So my triangle would look like this. A positive y, my negative 3 is going down. And I would think that intuitively you're just going to know that this is a 3, 4, 5 triangle. So x would have to be negative 4 since we're in quadrant 3. So now I simply go over here and plug in my values. And y'all, you're taking out the sine of alpha notation and putting in the numerical substitution for it. So then this just becomes arithmetic. Now, you are perfectly allowed to use your calculator, but give your answer in fraction form, exact form, not a decimal. Here I just multiplied negative times negative and got positive 12 times 2 would be 24, and 5 times 5 would be 25 in my denominator. So we said our answer here should have been positive, and it was positive. In our next example, we're being asked to use the cosine of an angle theta, which is 4/5, to find the tangent of that angle doubled. The original angle was in the fourth quadrant between 3 pi over 2 and 2 pi. So that means if I double the angle, I'm doubling the interval as well. So now my angle would be lying between 3 pi and 4 pi. 3 pi is 1.5 times around the circle, which would put me at 3 pi, and then 4 pi allows me to finish the unit circle on the second rotation. So I would be working in third and fourth quadrants. If I'm thinking about tangent in the third quadrant, it would be positive. If I'm thinking about tangent in the fourth quadrant, it's going to be negative. Now, this is the formula we're going to be using. But I got a major problem because they only gave me the cosine. So example 3 works like the previous example. I've got to think about cosine as being 4 over 5. X is positive. R is a positive 5. This is in the fourth quadrant, so I sketch it out, X, R. Again, intuitively, I think you're going to know that this is a 3, 4, 5 triangle with your y value being a negative 3. Now, do you remember that tangent is y over x? So that makes that a negative 3 over 4. So now I know my tangent value, and I can go right up here and plug it in. So I just rewrote my formula for myself so I don't get confused. So that's 2 times the tangent value, which is a negative 3/4. That 1 doesn't change. That's a minus sign. I'm going to square the tangent value, and I just show multiplying it by itself. And so at this point, I picked up my calculator and simplified it, which you can do. But if you pick up your calculator and work it, please put your answer in fraction form for me. Here is if you work it out the long way, which I did. If you do it on a calculator, Make sure that your final answer looks like mine, negative 24/7. If you try to turn that into a decimal, most of you would probably be rounding it because it's not a nice terminating decimal. So my angle to alpha obviously lies in the fourth quadrant because my tangent value was negative. Lastly, I have example 4, and I'm going to do this problem 2 different ways, and I think you can see on your paper how I'm asking you to do it. Right here I have the sine of x to be 8/17, but I'm asking you to find the cosine of twice x. My original interval was between pi/2 and pi, which means it was in the second quadrant. But if I double my angle, I'm going to be now lying between pi and 2 pi. So that means my angle 2x is either in third and fourth quadrant, or it is in the cosine in third quadrant would be negative, cosine in fourth quadrant would be positive. So obviously the easiest way to do this would be to use the sine problem. Cosine of 2x is 1 minus 2 sine x squared. I wouldn't have to do anything but plug that into the formula. So sine, we know, is 8/17, so I'm plugging that in, squaring it, 1 minus 2 times that, showing where I squared it. And then from here, I just simplified it out on the calculator. And you can too, at whatever degree you do. Just make sure you don't make any careless mistakes. Now, just for practice, I ask you to also use this form. This would require more work, and if you were allowed to do whatever form you wanted to, then you would probably choose the one I did originally. But if I said use this particular form to find the cosine of 2x, then you would have to do what I've asked. Okay, now we know we have a problem here. While we know sine of x, so we don't know cosine of x, so that takes us back over here to that triangle. Sine is 8, r is 17, y is 8, r is 17, x is going to be some negative number because it's over here to the left. I don't know if you remember, r is equal to the square root of x squared plus y squared. If I want to get rid of that square root sign, I have to square both sides, so this becomes 17 squared equals x squared plus 64. I would subtract that 64 from both sides, and that becomes 225 is x squared. I'm picking x to be negative 15, not positive 15, because we are in the second quadrant and we have to go to the left to be negative. So that makes my cosine a negative 15/17. And then if we try this form I've asked you to use, I plug in my cosine, negative 15/17, and square it. Minus, I plug in my sine, 8/17, and square that. Punch it into your calculator, and you get 161/289. Now this is not that difficult, but the answers just kind of freak us out because there are these fractions that we're not used to working with. But see, both of my answers were the same, so I'm confident that I did it correctly both ways. And our angle would have ended up in the fourth quadrant because cosine was positive. Now these 6 problems are your homework for today. It says to please complete your work on notebook paper. Please use spacing. See how I'm trying to space everything out so it's easy to read? So please do that, because it takes me a lot of time to grade your work off of the iPad, and then when it's all bunched up, it takes me that much longer. The first 3 problems use the same given. They're using this information right here for cosine, sine, and tangent of 2x. 4, 5, and 6 are different problems with different givens. So use your notes, and there are examples in your book if you need to look there. Good luck.